Okay, so let's continue with question number 5, which is on the uniform distribution. Okay, so we are done with the questions for normal distribution. Okay, we are now look at the questions for uniform distribution. Okay, yeah. So number 5, they're saying when a baby is born with underweight, okay, it may weigh 2 kgs. Okay, however, a healthy baby is born with a mass of about 5 kgs. We can thus conclude that the birth weight of the baby is from 2 kgs to 5 kgs. Okay. And then they're saying, suppose the birth weight of babies is uniformly distributed, and we are interested in the birth weight of a randomly selected baby. Okay. So the first question here, they're saying, find the PDF of the babies, the PDF of the weight of the babies. Okay. So the most important word here is this one here, where they say it's it's uniformly distributed. Okay, so the uniform distribution, it has its own formula for the PDF and the CDF, just like that. Okay, the mean, the standard deviation. Okay, so under the uniform distribution, the PDF is given by this. Okay, f of x is equals to, okay, 1 over b, okay, minus a, for the interval of a all the way to what? To b. So this is how the PDF, and then we say 0 otherwise or elsewhere. Okay, so this formula here is the general formula for the PDF of uniform distribution. Okay, all right, so let's now find what we've been given here. So here they're saying we can thus conclude that the birth weight of the baby is from what? 2 to 5. So our A in this case will be 2, our B will be what? 5. And then they're saying find the PDF of the birth weight of these babies. So this is what we're going to do. So since our A now is 2 and our B is what? Is 5, we're just going to replace into this function with those 2 numbers. Okay, so we're going to say the PDF, which is a small letter f of x, will just be equals to, okay, 1 over what is 5, what is b is 5 minus a, which is 2, for a is 2, okay, all the way up to what? 5. So we're just replacing the b's and the 5. Then we say 0 elsewhere or otherwise. It's the same. Okay, so this here will be the PDF. We can go further and simplify this one here. So we are just going to have what? We're just going to have 1 over 3, and then here 0. Okay, and then this one will come from 2 all the way up to 5, the values that it will take, and then it will be 0 elsewhere apart from what? This interval. Okay, so this is what, so this one here is our PDF. So we've answered the B question there. Okay, and then let's look at the C1. So C here, they're saying find the probability that a baby has a birth weight of between 3 and 4 kgs. And then this one is more than 4 kgs, and then this one not more than 4 kgs. Okay, so how do we find that? Okay. Okay, so to find the probability, we use the CDF of a uniform distribution. Okay, so remember I said the PDF for the uniform distribution is this guy here. So you just have to know the formulas. So the CDF for the uniform distribution is given by this. Okay, so CDF, which is indicated by a capital letter F like this, for a uniform distribution is given by this formula. You have your x minus your a divided by kb minus a. So this is the formula for the CDF. So you just have to master those two formulas. One for the PDF, one for the CDF, okay? And then we know the value of A, okay? A, we know it is 2, and then B, we know it is what? 5. So this X here, it will be the value that will be changing, and we are finding the probabilities, okay? So what was the first question here? The probability that, find the probability that the weight of the baby is between 3 and 4, okay? So how are we going to solve this? We are going to say the probability, okay, of X being between 3 and 4. Okay, so the probability of X being between 3 and 4, that's what we are finding. This is the same as, okay, the cumulative distribution of 4 minus the cumulative distribution of what? 3. So we know what this represents. It is given by this formula here, and this one is the same. So for this one here, the X will be 4, and then for this one, the X will be 3. But for A and B, they are constant. A is 2, B is 5. So we are going to say this. So we are going to say 4 minus 2, okay, because this is X minus this, and then divided by 5 minus 2 minus, here we are going to say 3 minus 2 divided by 5 minus 2. Okay, so from here we have common denominators. We're going to have 2 over 3 minus 1 over what? 3. And then when we subtract this, it will just be what? 1 over 3. So this is the probability of the weight of the babies to be between what? 3 and 4. Okay. All right. Then the other question was find the probability that the weight of the baby, okay, is greater than 4. So I said what? Whenever you have a greater than here, you always have to change it to a less than. So this will be 1 minus the probability of X being less than or equal to what? 4. Okay. And then from here, 1 minus this one here, it will just give us F of what? 4. Okay, and how do you find this F of 4? We are using this formula here. So where there's X, we are putting 4 here, 2, 5, 2. So let's put, so this will be 1 minus 4 minus 2. 5 minus 2. Okay, so this would be 1 minus 4 minus 2, it will give you 2 over 3. Okay, so let's subtract this. We know we can write 1. We can write 1 as 3 over 3. Then minus 2 over 3. Okay, so this will just be 3 minus 2, which is 1 over what? 3. So we also find the answer there to be 1 over 3. Okay, and then the other one now is the probability that X is less than or equal to 4, which is just the same as the cumulative distribution of 4. Okay, so from here we see that this will just be 4 minus 2 divided by 5 minus 2. So this would be what? To be 2 over 3. That would be the probability that the birth weight of the baby is less than 4 kg or it's equal to 4 kgs. Okay, and then let's find the mean and the standard deviation. So the mean here, it also has a specific formula. So under uniform distribution, you just have to master the formulas, okay? And then even the standard deviation, it also has its own formula. Okay, so let me show you the formulas. So for uniform distribution, okay, the mean, okay, you can say the mean is equals to the following. So mean is equals to, you add your A plus B, and then you divide by 2. It's very simple, okay? This will be your mean. So this will just be what? 2 plus 5 divided by 2. So this will give us what? 7 over 2. Yeah, so the mean will be 7 over 2, which is the same as 3.5 in decimals. Okay, so this is the formula for the mean, A plus B. This should be B. Let me write it properly. Okay, so this will be plus B. And then the standard deviation, okay, it also has a special formula, okay? So standard deviation under the uniform distribution is just equals to this. Standard deviation is equals to B minus A divided by the square root of what? 12. That would be the standard deviation. So we are just going to say what? 5 minus 2 divided by the square root of 12. So this would be equals to 3 over, this should be square root of 12. 3 over square root of 12. We punch this into the calculator, it will be approximately 0.866. This will be our standard deviation. Okay. So under normal distribution, guys, the questions will always very simple. The only bad part is that you have to master all the formulas. Okay. So master the formula for the PDF, for the CTF, for the mean, and for the standard deviation. Okay. Meaning when they ask for the variance, you just square the standard deviation if they ask for the variance. Okay. All right. So let's look at question 6. I'm sure it's also on the distribution, the normal distribution. The uniform, I mean. So they're saying the time in days for which an STI shows its symptoms follows a uniform distribution, okay? Where X goes from 25 to 45 days, okay? So it means this 25 is our A and our B is what? 45. So here they're saying write down the PDF of X and sketch it, okay? So let's do that. So here we've been given it runs from 25 to 45. So this is our A, this is our B, okay? So we know that the general formula for the PDF of a normal distribution is what? Okay, the general formula is this. Okay, it's 1 over B minus A for the range A all the way to what? To B. And then it is 0 elsewhere. Okay, so now from our question, we could tell that our A is 25, our B is 45. So it means our PDF will be in this form. So our PDF, okay, will just be equals to 1 over 45 minus 25, okay, from 25 all the way to 45. Okay, so this one here will be our PDF. Okay, and then they're saying sketch this. So how do you sketch this? Okay, so you just draw a rectangle, okay, starting at 25 and ending at 45 with a constant height of 120. Because when I subtract this, okay, I'm going to get what? 120. So this is how my sketch is going to be. So uniform distribution means on this side, I have the values for the f of x. And then on this side, I have the values for the x. Okay. So for the x, I can put 25 somewhere there. And then I can put 45 somewhere there. So to sketch it, I'm just going to go a height of 1 over 20 up. And then I go like that. And then I go down. So here, the height will be 1 over 120. 1 over 20. How did you get this 1 over 20? From the PDF here. 1 over 45 minus 25, you get 120. So this is your height. And then the x values are this. So this one here will be the sketch. So this one here will be the probability from 25 to what? 45. Okay. And then they're saying, the next question is what? Okay, they're saying find the probability at the time at most 35 days. Find the probability that the time is at most, okay, at most 35 days for an STI to show up. And then they're saying sketch the graph of the distribution and shade the area of interest. Okay, so at most, meaning what? Meaning that x is less than or equal to what? 35. So that's what at most 35 days means. Okay, so meaning we are finding the probability of x being less than or equal to what? 35. So what did I say, or what formula do you use? What formula do you use for finding the probability? Okay, under uniform distribution. I said x minus a. Okay, let me write it like this. Okay, say the cumulative distribution f of x is equals to x minus a, and then b minus a. Okay, so this is what we get. So what are we going to do here? We are going to just substitute the 35 into here. So 35, where there's x minus, what was our a? Our a was 25 divided by b minus a. So b minus a is 45 minus 25. Okay, so let's find what is 35 minus 25. We are going to get 10. 45 minus 25, we are going to get 20. So we cancel the 0, cancel the 0. This will just be the probability of 0.5. Okay. Okay, so this here will be the probability. Okay, this here will be the probability of it being less than 35. Let's find for the other one. They're saying, oh, they said we also sketch, right? Okay, so let's sketch. So this is the probability here, 0.5. Okay, so how can we show it on the curve? Okay, so remember the curve that I had drawn area was something like this. It had 25 here and then 45 somewhere, right? So this is our x, and then here we have our f of x, which is our probabilities, right? So we had 1 over 20 somewhere, and then we said this whole area was being represented by this. Okay, but now we are finding the probability that x is less than or equal to 35. So it means 35 can be somewhere in between these two numbers. So the area that we are going to shade will be from 25 to 35 under the PDF curve. Okay, so this can cover it. So this one here, you can even see that it's on a mid. No wonder it's 0.5. Okay? This area here is what we are shading. It corresponds to this 0.5 here. It's just half of this whole area here. Okay, and then C, let's find C. C, they're saying what is the probability that the time will be between 35 and 40 days? Sketch and label the distribution. Okay, so let's find. Okay, so we are finding the probability, okay, that the x is between 35 and 40. So this is the probability that we are finding. So this is the same as what? This is the same as f of 40 minus f of what? 35. Okay, so you always start with the bigger value and then you say minus the smaller value. Okay, but we know that this one here will just be 40 minus 25 over 45 minus 25 minus 35 minus 25 over 40 minus 25. Okay, let's find. So 40 minus the 25 there, what is it going to give us? Okay, so 40 minus 25 is going to give me, it's going to give me 15, 15, right? Yes, so this will be 15 over 20 minus 35 minus this, it will be 10 over, what did I write 40 here? So here should be 45 because this is the B, right? So 45 minus 25, it's going to be 20 as well, okay? So 15 minus 10, it's going to give you what? It's going to give you 5 over 20, which will be the same as 0.25. So this here will be the probability that, okay, this will be the probability that the time is between 35 to 40 minutes, okay? All right, and then how do we sketch this? We do the same. So this is our original curve here, starting from 25 all the way to 45. So we're just going to add a 35 somewhere here and 40 here. Okay, so remember the total area is from 25 all the way up to what? 45. Okay, and then it goes like this. This will be 1 over 120 like this. Okay, so how are we going to set this? We're just going to shade this part. This part here. But this part here is the area that we are talking about. Okay. This is our this number here, our 0.25. Okay, and then they are also saying find the expected value. So the expected value is the same as the mean. So the expected value for a normal distribution will just be equals to what? A plus B divided by 2. Okay, so expected value will just be equals to, what was our A? Our A was 25 plus our B was what? 45 divided by what? 2. So this here is going to give you 70 over 2, which will just be 35. So our expected value is 35. Then the standard deviation. Standard deviation, we said its formula was B minus A over root of 12. Okay, so B is 45 minus 25, and then divided by root of 12. Okay, so what is 45 minus 25 is 20 divided by the root of 12. This will give you approximately 5.77. So this one here will be the standard deviation. Okay, so that's how you go about the uniformly distributed questions. Okay, just know the formulas. If you can't know the formulas, you can't solve any questions about the uniform distribution. Okay, right. And then number 8 is also on the uniform distribution. Okay, so I want to solve, I mean number 7, I want to solve this one here. But you can check the written solutions on Drive. Okay, the written solutions are there on Drive. I explained how I found the answer. Okay, and then okay, so let's look at something different, which is the exponential distribution. Okay, so the exponential distribution is different from the normal distribution. It also has its own what? Formulas. Okay, so let's look at question number 8. So question number 8 is on the exponential distribution. So we expect different formulas. So they're saying food samples must be tested before consumption. Suppose the rating of a food sample, particularly meat, is exponentially distributed with an average of 5 days. Okay, so the other thing on how you can know that this is an exponential distribution, you're in the question, you'll only be given the average. Okay, you'll only be given the average. So we can see here that we have only been given the average. Okay, so they're saying find the probability that a sample of meat takes less than 1 day to rot. Okay, B, find the probability that a sample of meat takes between 2 to 4 days to rot. C, they're saying what is the expected number of days, so that's just the mean. And then D, a butcher is selling this kind of meat processes to refund all its customers whose rating of their purchased meat samples is among the first 8%. Okay, and then they're saying correct 2 decimal places. Where is the cutoff number of days for the refund to take place? So let's find. So when you're dealing with an exponential distribution, okay, we have to know that the PDF is given by this. Okay. Okay, we have to know that the PDF under the exponential distribution is given by f of x is equals to lambda, okay, e to the power minus lambda x, okay, where x is greater than or equal to what? To 0. So this is the formula that you should know under exponential. There are no two ways about it. You just have to know the formula. Okay, so this x here will be the value that is given, like find the probability maybe more than 3. It means this x will be 3. Okay, and then this lambda here, it will be the parameter. Okay, so how do you get this parameter, the lambda? Okay, you say this lambda will be equals to 1 over mu. Okay, this mu here that I've written down here, it represents the average that you are always given in the question, or the I can say the mean. Okay, so the mean or the average is what this is. So in this question here, we are told that the average is 5 days. Okay, so that's what we are going to do, what to use there. So we are going to say the parameter lambda is equals to 1 over 5. Okay, 1 over 5, and then you can even divide this to just be 0.2. So it means we are going to be using it here and here. Okay, so let's answer the questions now. So the first question here is find the probability that a sample of meat takes less than 1 day to rot. Okay, so it means we are finding what probability? It means we are finding this. So the probability that x is less than 1. Okay, so okay, so this is the probability that we want to do what? To find. Okay, so if you're given a probability that is direct to the point, then you can substitute direct. But because this is a continuous random variable, we are going to use what? The cumulative distribution to find this probability. Okay, so this PDF for exponential distribution is given as 1 minus e, okay, to the power minus like that. So this is the formula that we are going to be using to find the probability. So they're saying probability of x being less than 1 is equal to the cumulative distribution of x being equal to 1. So we are going to say f of 1 is equals to 1 minus e to the power. What was the value of this lambda here? We said it was what? 0.2. So we are going to put 0.2 here. Okay, and then we are going to multiply with the 1. So 1 here. So it means we are going to have 1 minus this to the power minus 0.2 is equals to. So you get your calculator and then you punch in this. So you do e to the power minus 0.2. You see what you're going to get. So this will be 1 minus, and then this value here, it gives us 0.8187 when you punch this into your calculator. Okay, so this will be equals to 1 minus this guy here. Okay, 1 minus this guy here. You're going to get 0.1813. So this one here will be the probability that x is less than 1. Okay. And then the other question, they're saying that what? They're saying find the probability that a sample of meat take between 2 to 4 days to rot. Okay. So how do you find that? So this is the probability that I have this between 2 and 4 days. So we know that this one here is just going to be 4, f of 4 minus f of 2. Okay. So f of 4, it's going to be 1 minus e to the power 0.2 multiplied by 4 minus 1 minus e to the power 0.2 multiplied by what? 2. Okay, so we are going to have 1 minus 0.8 minus 1 minus e to the power minus 0.4. So this is what we get, okay? So you punch this into the calculator and then you subtract it from 1. So what am I going to get there? Okay, so when I punch this into my calculator, I'm getting 0.5507 minus, when I punch this into my calculator, I'm getting, I'm getting 0.3297. And then I subtract these two numbers to get the final answer. So this minus this, ending up with 0.2210 as my final answer. Okay, so that is the probability that it is between what? 4 and 2. Okay, and then what is the other now question here? They're saying what is the expected number of days of the sample of meat takes to rot? Okay, I already gave you the formula. So the mean, okay, is equals to the parameter, which is 1 over lambda. Okay, because remember how we are finding this guy here, the parameter. Okay, so the parameter, where is it? The parameter was equals to 1 over the mean. Okay, so it means if I want to find the mean, I just cross multiply and then I divide by lambda. So my mean will just be 1 over lambda. So this will be 1 over, what is my lambda? 0.2. So which will be, my mean will be 5. And we can check from the question. We're also told that the average is 5. So the mean being 5 makes sense. Okay, so the mean is 5 there. Okay, and then the last one, on the last one, we are given the probability, and then they want us to find the x, okay, or the cutoff point, the number of days. Okay, because here, let's read it together. Saying a butcher is saying this kind of meat promises to refund all its customers whose rating of their purchased meat samples is among the first 8%. Yeah, so they're saying correct to 2 decimal place. What is the cut-off number of days? So it means this one here is the probability that we've been given. And then they want us to find the number of days. Here they are giving us days, and then we are finding the probability. Okay, but here is the opposite. We've been given the probability, they want us to find the number of days. So we know that the probability, we are using the cumulative frequency to find it. It's 1 minus e to the power parameter, then x. Okay, so we want to find this x because this f of x here, which is the probability, has been given as 8%. We know that 8% will just be what? 0.08 in decimal like that. So this will be equals to 1 minus e to the power, what is the lambda? 0.2x. Okay, so we want to find this guy. We can take this to the other side. So it will be e to the power minus 0.2x is equals to 1 minus 0.08. So this is what we have. Okay, so this will be e 0.2x is equals to, So 1 minus 0.08, what are you going to get? You're going to get 0.92. Okay, and then how do you find this value of x? You introduce ln, even this side you introduce ln. So it means this power can drop now. So we are going to have what? Minus 0.2x ln x is equals to ln 0.92. Okay, from here we see that this one here will just be equals to 1. Okay, so we have 0.2x is being equals to ln 0.92. So we divide both sides by minus 0.2, in this side minus 0.2. So our x, which is the number of days, will be equals to. So you punch that value into your calculator. Okay, so be a minus here. Okay, so let me punch it. So we have minus ln 0.92. Okay, so we have minus ln 0.92. Then we are dividing this by 0.2. So we are going to get 0.417 days. Okay, so that's it for this question here. And then for question 9 and question 10, they are also on the same exponential. So you can apply the same concepts. Okay, so when you solve them, check with the answers that are posted on the drive. Okay, so you can see here it follows the exponential distribution as well. Even number 10 follows the exponential distribution as well. So you do the same as I was doing. Okay, and then you confirm the answers with the ones that I put on the drive. Okay, so have a blessed evening.